Hello everyone, welcome back to Pre-Algebra. We're using as our text Bob Jones University Press publications. We are using Pre-Algebra for Christian Schools. We're using the first edition. It has the same material as the second edition, but it does not, it's not presented in the same order. So either one of them will work as far as topics, but you can't track exactly with me unless you have the first edition. So first, before we begin, lame joke for the day, of course. Can anyone tell me how dogs are just exactly like telephones? Well, they both have caller ID. And then, what did the dog say when he sat on the sandpaper? Well, he said, "Roof," of course. We are on page 100, and not 100, we're on page 25, which is section 1.7 in chapter 1. We're talking about rounding numbers. This is just a very brief review, I'm sure, for just about everyone who might be watching this. But we're specifically talking about rounding whole numbers. Before we do that, I want to do a very quick review of how you name a number or what the place value of certain numbers is. And let me go ahead and set it up this way. I'm going to put 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, period, 1, 2, 3 places here. This is just a review of how we name a number. And something that you will hear very frequently, I notice it all the time on the radio. How would you name this number right here? Is it 1024 or is it 1024? This is real picky here, but there is some importance for when you're, like if you're taking dictation about numbers, and if it's not pronounced correctly, you write the wrong thing down. This is 1024. You do not say "and" unless you're working with a decimal number. Let me put some different names in here in just a second. But let's start with 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 1, 2, 3 again. And I'm going to read this number for you just as a review. This is 123,456,789 and 123 thousandths. Okay, how did I know exactly what to say? Well, hopefully we've learned it before now, but some ways that makes it easier if you're struggling. This first comma here, actually, if you want to count from the decimal point out, you have your first comma and your second comma. He has a name, and this guy's name is Million. This guy's name here is Thousand, and this guy's name here is And. That's the only time that you're ever going to pronounce an and when you name a number, is if you're pronouncing the decimal point. And you see this as 123,456,789 and 123 thousandths. So that way they have this broken up into groups of 3. You just read each pairing or each grouping of 3 digits as though it were a number from 1 to 100. Well, Miss Betsy, what happens if we have 3 digits paired together here, or grouped together since a pair is 2? And we have something that looks like this. Do I read 039? No. That's just read as 39. In each grouping of 3 digits, if you have, this is what they call a leading 0. If you have a 0 in the beginning, you just don't pronounce it. And of course, if we had something that looked like this, you would read this as 309. The 3 indicates that you have 3 100s. You have 0 times 10. And here you have 9 times 1, or the units. So you have 300s, which is 300, no 10s, in 9 little individual units. So you have 309. Now, watch how I put these commas here in the decimal point, and I named them million, thousand, and for right now I'm going to leave that 123 thousandths. So let's go ahead and change this number here. What if I have 7 0 0 0 0 0 2.123? We're going to read these numbers in groupings of 3. 7. Now we need to read the commas name. 7 million. What is this? Nothing. When it's all zeros, you don't read it. You don't read that comma name. So you have 7 million. How many do we have here? Ignore those first 2 zeros in the group of 3. 7 million, 2, and 123 thousandths. What you'll want to remember is the names of these places. This is where we talk about place value. The 2 is ones. Sometimes they call it units. This is just singles. Tens, hundreds. Now, this comma right here, his name is thousand, so it's 1,000, 10,000, 100,000. So right here is 1,000, 10 thousands, 100 thousands, 110 1, 110 1,000. What are we going to have over here? Exactly right. We're going to have ones, but it's at 1 million, 1 million, 10 million, and you have 100 million. So this is in the 100 millions place. So we would have 207 million, 100,000, 682, and 123 thousandths. 207 million, 100,000, 682, and then we have the place values to the right of the decimal point. Let me go ahead and erase this so that I can better illustrate what you do with the place values to the right of the decimal point. My other rooms are not available right now, so we're just bearing with me on this tiny little board, but you can still get the point across. So here we have tens, hundreds, thousands, hundreds, tens, units, ands, tenths, hundredths, thousandths, 10,000ths. You have your units here, which is like saying ones. We have our tens. We have our hundreds on the left-hand side of the decimal point. And we continue moving along up, multiplying by 10 each time. 1,000 times, 100 times 10 is 1,000. Times 10 is a 10,000ths place. Times 10 again is the 100,000ths place. Well, here we don't have oneths. And I have a terrible time pronouncing these things that end in THS. So this is the tenths. This is the hundredths, 100ths. This is the thousandths place. Thousandths. and this is the 10,000th place. So when you read a number that is a fractional number, it's a decimal number that it's not a whole number, this would be 123 and 4, 2, 6, 5. What you do is you read the number on the right-hand portion of the decimal point as if it were just a regular whole number. 4,265, and then you say the name of the place value. This place value is the 10,000ths, 123 and 123 and 4,265 10,000ths. If we didn't have this one here, this would be 123 and 426 thousandths. If we had this, what would we have? 123 and 406 thousandths. Now, what if we have leading zeros here in front of our fractional, in front of our decimal portion? 123 and 6 thousandths. So that's all you do to name numbers, but you have to have an understanding, you have to have a knowledge of what those place values are in order to round. Because what they're going to ask you in your book is say, okay, take this number and round it to the nearest tenth. So if we have 786, and they say round it to the nearest tenth, what do you need to do? First thing you have to do is you have to identify the place to which you are rounding the number. Here we're rounding it to the tenths place. So what you do when you round a number, you're looking at the digit that is directly to the right of that. If the number is 5 or above, let's say 5, 6, 7, 8, or 9, then what you do is you round up. What am I rounding up? This digit right here that says round to the nearest tenth. So what we're doing is we're looking at that digit there. We're determining if we're going to keep it an 8, or if we're going to round it up, or if we're going to increase it to a 9. In order to do that, what you do is you look at the digit directly to the right. If that digit is 5 or greater, 5, 6, 7, 8, or 9, the digit in the hundreds place here would round up, which it is. So 786 is approximately 790. Those two little squiggle things mean is approximately equal to. Now, the other thing that could have happened, we have 786, not 86, 784. And we want to round that also to the nearest tenth. What do? We have the place to which we are rounding it, which is the hundredths place. Now we're going to look at the digit directly to the right of it. If this is a 4 or less, if it's a 4, 3, a 2, a 1, or a 0, our digit stays the same. Some people say it rounds down, but we're not changing the number. So the number that is in the place to which we're rounding remains the same. Here, we round it up to 790 because we increased that digit by 1. Here, what we're going to do, because we're rounding to the tens place, this digit here is a 4, which is less than 5. We take this number here and we drop it down. We're moving this number down, keeping it to 780. It's like we have 780 and we have 790. We're going to have all these numbers in here. We're either going to round it up to 790 based on the unit that's in the digit that's in the unit places, or we're going to round it down to 780. If we have these continuum here, let me do 720 and 730. What's going to happen if we have 732 and we want to round that to our nearest 10? Let me make this fit my illustration. 722. We want to round this to the nearest 10. We have 722. Rounding to the 10, we look at that digit, which is less than 5. So you're going to round down. The end digit becomes a 0, and you have 720. You've rounded down. If this digit, however, at the end of this number, 725, rounded to the nearest 10, we look at the units, it's a 5, so you're going to round that one up to 730. I'm really hopeful that all of this stuff on rounding numbers up and down and on place value is a review to you, but if it isn't, play around with it until you figure out what's going on. Basically, you have to make sure that you understand place value, that you read your instructions clearly, and that you know when you round up and when you round down. All it's really saying is, look at these two numbers here. I have 100 and I have 200 and I have 176. Is 176 closer to 200 or is it closer to 100? And what you do, here this says round to the nearest 100, or round to the nearest 100. We look at the digit in the hundreds place. We look at the next digit, which is a 7. Because it's 5 or above, when you round 176 to the nearest 100, you move it up to 200. So 176 is approximately 100. However, if we had 149, you can see that 149 is just almost exactly in the middle between 100 and 200. How do we know if it rounds up to the 200 or if it rounds down to the 100? Well, what you do, look at the digit immediately to the right of the place to which you're rounding. We're rounding to the hundreds. We look at the tens. It's less than 5. So 149 rounds down to 100. So that's what you're going to be doing when you're rounding. What if we want to round something to the nearest 10,000? And we have this number. We have 8,246,001. Not 8,246,001. There's no decimal point there. This is 8,246,001. And our instructions say round to the nearest 10,000. First off, you have to remember units, tens, hundreds, thousands, 10,000s. So we are going to round to this place right here, which is a 10,000s place. How do we figure out what we're doing? We look at the digit next to it. If the digit next to it is greater than 5, is 5 or greater, this rounds up. 8,000,000 to 5. The 4 goes up to a 5. Everything else is a 0. Because what we're doing is rounding to the nearest 10,000. 50,000, 60,000, 70,000. So when you round up, every digit to the right becomes a 0. Same thing when you round down, the remaining digits in the places to the right of what we're rounding to. See, this would round to about 8 million, but it didn't ask us to round it to the nearest million. It asked us to round it to the nearest 10,000. So this right here rounds to the nearest 10,000, 8,250,000. What if we wanted to round it to the nearest 100,000? Okay, we've got the 4 here. It's going to round down, so we have 8,200,000. And now, if we want to round it to the nearest million, we look at the digit to the right of it, round down. So you approximate this number according to which digit, according to which place value you're rounding it. You can estimate it as 8 million, 8,200,000, 8,250,000. This is rounded to the millions, 100,000s, 10,000s. There's one other way that you can estimate numbers, and this is what they call front-end estimation. And I might use this a lot when I'm out shopping and I'm trying to keep track of how much money I'm spending on my groceries. What you do is, let's say that we have y is equal to 373 plus 224. And we want to estimate what this sum is. So this is front-end estimation. Front-end estimation. Well, what do we think it might have since it says front-end? Well, it's talking about take the digit at the very front of each number. So we have 300 plus 200. That's 500. How did I know it was 300? Because it's in the hundreds place. 3 100s, 2 100s. 3 plus 2 is 500. But we didn't use everything. We left this material there. We can sort of just roughly group those together. 75, 25, that's plus another 100. Or you could actually go ahead and round those. Are they closer to 100? Are they closer to 0? 73 rounds up to a 100. 24 rounds down to 0. So regardless of if you just grouped them together like I did or you rounded them to the nearest 100, you have an additional 100 that you add on to. So you have approximately 600 being the sum of this. If you had rounded these numbers individually to the nearest 100, you'd have the same thing. 373 rounded to the nearest 100 would round up to 400 because of that 7. 224 would round down to the nearest 100 to 200 because the digit in the tens place is a 2. That's what they're asking you to do with front-end estimation. And that's the conclusion of section 1.7 and actually the conclusion of the entire chapter 1. Go ahead and review what you've done and be ready for a test. So, have a wonderful time till I see you again.